So we've seen that lithostratigraphy really is used extensively for mapping rock units. So it is essentially a field method. So let's talk about how we can use different methods in the field to build a stratigraphic log, and then by extension correlate the units that we see in the log laterally. There are several methods you can use to measure thickness of stratigraphic units. And the first thing to realize is that when you are in the field, the thickness that you measure is never the true thickness of a unit. And the reason for that is that you very rarely have the luxury of being able to measure the thickness of a bed along its main axis. Most of the time, the bed is tilted because of tectonic, and so the distance you measure tend to be greater than the true stratigraphic thickness. So to overcome that, you can use two different methods. The first method effectively relies on using trigonometry. If you know at the outcrop the distance between two beds at the surface, and you know the angle of the bed, which you can measure with a clinometer, you then have a way of calculating, using Pythagoras' theorem, the true thickness of the formation. So that's the first method that you can apply, which is a mathematical way of determining the true thickness of a stratigraphic unit. The second method is actually simpler, and it relies on using a tool known as a Jacob's stick. A Jacob's stick is effectively the second method is actually simpler, and it relies on using a very simple tool known as a Jacob's staff. A Jacob's staff is a T-shaped piece of wood, and what you do is you put gradation on the bottom part of the piece of wood, so you know typically if you have 1 meter, 2 meters, etc. And you use the T to be able to project the horizontal of the beds. So effectively, that relies on you walking the outcrop and projecting horizontally parallel to the bedding plane your Jacob's staff, and thus you can estimate the thickness of the beds. Now, I've used both methods, and in the field I have to say, even though the Pythagoras method seems to be more scientific, because of the cumulated errors that you have in measuring angles and measuring distances, it tends to be less accurate and much slower. So I do actually tend to favor now using a Jacob's staff. But that has been a change of heart about 5-6 years ago. Before that, I was a big believer in just using mathematics and the more scientific approach. But taking measurement is not enough. You also need to know how to report them, and taking clear notes in the field is absolutely essential. So how do you go about doing this? Here's a good example from a book I highly recommend by Ko et al., where they show how you would actually in the field draw a sketch of your log. So on that sketch, we'll see more details later, but you can put the type of grain size that you have. So at the bottom you see they have a scale for the different grain size. How far the bed extends is a function of the grain size, and it is also a function of the weathering profile, because coarser grain size tend to weather less easily. And then on top of that log, which is actually not captured necessarily to scale in the field, but with clear annotation of distances between beds, you can add information about potentially the presence of bioturbation or of fossils, or where you took different samples, and then you can put handwritten notes that really explain what you saw. For instance, if you find coals or chalk or different elements. So field notes are absolutely essential. But of course, field notes is not the end of the story for stratigraphy. Once you have field notes in the field, the idea is that you come back to your hotel room or the house you're living in when you do your mapping, and you take those notes and immediately transcribes them into something that is more to scale and more usable. And the reason for this is that memory is really short-lived, and so what you see today in the field you will have forgotten tomorrow, and it's absolutely imperative to make that translation as soon as you can. So here's a good example of a handwritten note transcribed into something much more usable. So this is a computer-based log, and that's what I will ask you to do today. Try to get as much as possible a computer base logged, and you can see that the information here is very clear. So we still have the grain size. In this case, we're dealing with sandstone, so we'll use the sandstone grain size. So you go from very fine all the way to very coarse, and you have clay and silt at the lower end. How far the bedding extends is a function of the grain size. Sometimes you could have a mix of grain size, and if that's the case, you put the bed that extends to the middle interval between the two grain sizes you want to capture. And on the log itself, you can see that the author has indicated the lithology, so that's how far it goes, but also bed form. So you see cross stratification, for instance. You see large cross bedding for dunes. You also see the nature of the contact. It's very clear that some of those contacts are erosive because they show channelization, and at the base of the channel you can see even the presence of pebbles, of coarser pebbles. And then on a separate column, the authors have indicated the different fossils that they have identified. Which is also important is to indicate the key. What do those symbols mean? And so on a graph, you always want to have a key so that your reader can essentially interpret your log as well as they can. Notice that this log starts at 0. Now 0 is an arbitrary reference, it's just a point in the section, and this is a land-based section. And the reason I know this is because 0 starts at the base and then meters go up the scale. So that's typically the way you would report a log on a cliff, for instance. You naturally start at the base, the older sediments, and you move your way up towards the younger sediments. If this was a core, taken by the JODIS resolution on which I sit now, it would be the reverse. You would actually start 0 at the seafloor, which is your first reference, the first sediment that you see, and numbers would increase as you drill down into the sediment. So that's a major difference between cores versus outcrop, is the way in which the stratigraphic direction goes. You can also use more information or put more information into separate columns. So this is the same log as before, but notice here that the authors have actually split the lithology. So you now have a clean lithology column with what the lithology is, and the bed form and grain size. And that makes it a little easier to see because you no longer have the bed form drawing on top of the lithology. Now, which one you choose is up to you. Both are valid. Sometimes it depends on how much information you have. If you have a simple log to draw, the first method is preferable. But if it starts to be a complex log, then this is a preferable method. And you can also indicate the fossils here separate and even indicate whether you have a body or a trace fossil in those columns. And you can add more things. You could add bioturbation, you could add the presence of pyrite nodules, you could add an information on diagenesis. You know, you're not limited in the number of columns you can add to this type of report. But this only gives you information on the vertical succession of rocks, right? If you do a log, you have a good idea of how the sediments vary laterally. And that's fine. That's most of the work is done this way. But what if you have an outcrop and you're interested in the lateral continuity of some particular beds, if you want to study pinch-outs, for instance? Well, you can do this as well. Here's an example from one of my former PhD students that we did in Oman together. And you can see here the goal was really to capture the nature of the lateral succession of these carbonate rocks there from the lower Cretaceous. And the way we did this, or my student did this, is by doing photopanoramas of the whole cliff and then go and take several logs at the outcrop itself, so following the method I've shown you before, measuring them, etc. And once you have this, you combine the panorama with your log and you trace some key beds laterally, so you actually have to walk from one log to the other log to make sure that you have the correct correlation. And then you can start drawing with all of this information the 2D to 3D geometry of beds. So it is absolutely possible to do this at an outcrop and capture the 3D or 2D geometry of the rocks. You're limited by what is cropping out. It's never perfect, but nevertheless, you can reconstruct the different heterogeneities that you find in the stratigraphic record, and this is something you might want to consider when your time comes to map rock units. Okay, that's it for lithostratigraphy. Next week we'll talk about chronostratigraphy.